this video, I'd like to continue the series on a math question each day. And for today, January 18th, 2023, we need to find the area of this composite shape here. And this shape we can see is composed of a rectangle, this triangle here, and this triangle right here. So to find the area of the entire shape, we essentially need to find the area of each of these pieces. Or in other words, we need to figure out how much space this shape takes up. And this can be a little bit challenging. We do need to have some understanding of geometry and pre-algebra, but we will also need to know how to deal with right triangles. So at this point, go ahead and pause the video, see if you can solve this for yourself. Spend at least a few minutes thinking about this or attempting the problem, even if you are not sure what to do. And when you feel like you are ready for the solution, go ahead and replay the video. So go ahead and do that now. And at this point, I will assume that you have attempted the problem. Now, let me make a little bit of room. And the general strategy here is to find the area of each of these pieces individually, and then we can just add them together. So let's start with the simpler pieces. We can start with this rectangle. And remember that the area of a rectangle is just the base multiplied by the height, or you can say it's the length multiplied by the width. It doesn't really matter. The main idea is that we're going to be multiplying these two dimensions together. So in our case, we have 6 for its height and 12 for its base. This would also be 12. Let me put that down below here. So we can multiply 6 by 12, and 6 times 10 is 60. 6 times 2 is 12. So this is equal to 72. And we don't have units, so we can just say this is 72 square units. Now for this triangle right here, we have its base, and we know for a triangle that its area formula is 1/2 the base multiplied by the height. And again, we have this base of 5, but we aren't explicitly told the height. However, this is a rectangle. So in rectangles, opposite sides are equal length. That's how we knew this was 12. This length right here would be 12. And we can deduce that this height right here would be 6. And finding the area of this triangle, we take half of the base, which is 5, and multiply by the height, which is 6. This is 30. We divide 30 by 2, and we get 15. Now at this point, we just need to figure out the area of this right triangle, and it looks to be an isosceles right triangle. This side here and this side here, these are equal to each other. And we know the hypotenuse of this triangle. What we can notice is that, let me change colors, this length right here, which I'll put in blue, is just the sum of this length from the rectangle and this length from the triangle here. So if we add those together, we have 12 here and 5 here. This entire length would be 17. And to figure out the legs of the triangle, since we need to know these to use the area formula, we will need to use the Pythagorean theorem. And remember that for some general right triangle, that if its side lengths are a and b for the legs and c for the hypotenuse, then the relationship between these three sides is just a squared plus b squared is equal to c squared. And we can apply that here. If we just give these some variable name, let's call each of these x, and then we can solve for that. So we have that the two legs, that's a and b, we're going to square them and add them together. So we have x squared plus x squared, and this is equal to the hypotenuse squared. So we have 17 squared. And if we combine these, we get 2x squared. 17 squared is just 289. And at this point, we just need to take a square root of everything, though let's first actually divide by 2. So we get x squared is 289 over 2, and now we square root everything, meaning that x is the square root of 289 over 2. And when taking the square root of a fraction, we can take the square root of the top and the square root of the bottom. But we know the square root of the top is just 17, since we know 17 squared is 289. And for the bottom, we can just write that as root 2. Now, if we want, we can even rationalize this. We can multiply top and bottom by root 2 so that we get the square root out of the denominator. Since in the top we'll get 17 root 2, and in the bottom, root 2 times root 2 is just 2. Now, with this information, we now know the lengths of each of these legs. These are each 17 times by the square root of 2 over 2. Let me make just a bit more room. And we need to find the area of this triangle. And we know that the area formula is half the base. We can call either of these the base. So we have 17 root 2 over 2 multiplied by the height, which would be the same number, 17 root 2 over 2. And we can see if we multiply these fractions, we're just multiplying straight across. We get 17 times 17, which is 289. We get root 2 times by root 2, which is 2. And in the denominator, we have 3 2's multiplied together, which is 8. We can cancel a 2 from the top and the bottom so that we get 289 over 4. And if we want, we could make this a decimal, but the main idea at this point, we know this area is 289 over 4, is to add all of these areas together. So I can scroll over so that we can do that, and we can look at the total area, which again is just the sum of these. We have 72 for the rectangle. We found this triangle was just 15, and we're adding 289 over 4, though we can make this a mixed number or a decimal just to make it a little bit easier. This would just be 72.25, and if we add all of these together, 72 plus 15 plus this 72.25, we get 159.25, and since we didn't have units, we can just say we have square units.